So thank you very much indeed, Iman. Thanks a lot, man. Great presentation. And actually, you spoke about Node.js, and I'm going to follow up on that because the API I have prepared for today's presentation is based on Node. So the theory you explained today to our audience, they will see it working with real code, right? So hopefully both are complementary. Thank you very much to JavaScript-Exchange and the organizers for having me today. It's an honor and an absolute pleasure that I'm here with you today speaking from Madrid. And before starting, I just want to mention and tell you to all the audience and the organizers and the panelists that I hope that you guys are in good health and good shape with this situation with the COVID. I know it's hitting hard, but I hope that you guys are doing well, okay? Good health, good shape, and that we are creating amazing stuff with code, okay? So I'm gonna share my screen, and I'm gonna, guys, that I have 20 minutes today, so it's 7 o'clock in Madrid, 6 o'clock in London. So I will try to do my best to be right on time. Can you see my screen, guys?
Yeah, all good, Dani.
Thank you very much. So I'm gonna start presenting. So there you go. Today I'm going to create and show you how to create these exoplanets visualization in Three.js that I will show you in a second, how it looks and what it is. So my name is Dani Vicario. And I'm a certified technical trainer and an Adobe web specialist working as a senior engineer at Busuu. It's a company where we develop course languages to the highest standards. And although I work there today, I'm going to be speaking about, not about languages, but about astronomy. So hopefully you like the presentation I have prepared today. In this presentation, I am including a presentation that, by the way, then later on through the organizers you will receive. I'm giving you a link where you can leave the feedback that you want. Hopefully you like this presentation and you feel after it as much passion as I feel for astronomy and data analysis and data visualization and 3D. And this is something that I wanted to mention as well. So here is the code. Every time I give a presentation, a workshop, a seminar, I speak in a conference, I always give away my code. I have received so much from the society and the community, and I want to give back for sure, okay? So I believe in karma, and I believe that everything I have received from society, well, it's amazing if I can give something back in exchange, okay? So here's all the code of everything I'm gonna be talking about today. And so speaking about astronomy, before I show you this, where's an exoplanet? Actually, I want to show you what we are going to be building. Okay, so is this. So what you see in here is a fantasy texture exoplanet, which actually is real. So an exoplanet, for those of you that don't know what is I know what a planet is, but I don't know what an exoplanet is. So an exoplanet is one planet that is outside of the solar system that has been detected using really sophisticated astronomical instruments and devices. And NASA is really kind, offering all that information to us through really nice APIs. So Iman before was talking about APIs. So actually I'm going to create my own API using Node.js, and I'm going to consume NASA's API. So from my front end, I'm going to be consuming my own API, and my own API will be serving me one slice of the whole data that I'm receiving from the NASA servers, right? And this name you see here, HT, blah, 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 and this number, they look very strange, but actually this is a real name from a real exoplanet, which actually is the biggest exoplanet that we have detected so far, which is 6.9 times bigger than Jupiter. So that means that it's massive. So, you know, imagine like a small star, you know, it's super massive. But also, I don't want to show you this. I want to show you this, which is a navigation through the 10 biggest exoplanets. And all these textures you see here, I made them by code. So I love HTML5 canvas, and I want to show you how you can make these. So I can zoom in. I can pan around. The stars are generated by code as well. See? So all these textures, this is where I plan to build real names again, real data from NASA, really, I hope, hopefully really cool for you, because this is real information from astronomical devices, you know, and in the browser, working with open standards, which is something that never stops amazing me, you know. It's incredible that we can do this for free with open source tools, and that's why I'm giving you my code away. So what is a transit? How do you detect one planet that is so far away? Actually, you know, really far away. So outside of the solar system, there is this way, when you are outside the solar system, there is this way called the transit detection mode, which is this, right? This super short video, 25 seconds, right? So this is a star, and this is a planet. It is so far away we cannot see it, but we can measure the brightness of that star over time. So say you orientate a telescope towards one star that we know, and it's fixed. It's always looking at that star. And then what you do is you measure in the brightness over time, right? So what happens that we cannot see this planet, but we know we can, because we can see that because this planet is now in front of the star, we can detect a decrease here in the perceived brightness from the Earth, right? And when the planet goes away, orbiting back behind the sun, we can see an increase in brightness, right? So that's the transit mode, transit detection mode, which is awesome, right? You think about it, it's incredible that by looking in a fixed manner to one star, we can detect over time brightness variations, and therefore we can see that something is there, you know, blocking the light, right? It's awesome. So the next slide in my presentation is the last one, because we have only 20 minutes. And in this presentation, I am including you this link. And by using this link, you come here to the NASA. This is the Exoplanet archive. And I simply downloaded the JSON format in JSON format, which is something that, by the way, Iman was mentioning before, this JSON format, which is native to JavaScript. This is JavaScript objects in a native format that JavaScript understands right away without any type of intermediate parser or any intermediate tool. So this row, these are the all confirmed planets, which is incredible, right? I'm going to show you in my source code where I have this JSON. So I have these planets.json here. Oh, sorry, the JSON here. Sorry. So this is it, right? This is the document I downloaded. So you basically have to click here, and that is the document I'm showing you here. So incredibly enough, see, 4,202. So we are kind of stuck with Pluto, Jupiter, the Earth, Mars, blah, 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 right? But actually, there are 4,000 already detected, which is incredible, right? And by the way, many of these planets are detected also using artificial intelligence, machine learning, and these things, right? So here we have lots of data. Let me show you only one. So I'm going to get this one, just one row. I'm going to open here the console, and I'm going to create, increase the font size so you can see it better. And here, if I say let planet equals this thingy, okay, and now I clean and I do planet, now you can see all the properties having parsed by the browser, right? So you have things like the name, the planet host name. Sorry, so this is not actually the name. This is the name of the star is orbiting around. But the planet name is this field. So it's hat P70b. Okay, so it has two fields that I am interested about. So the two are PL name. PL name stands for planet name, as I mentioned before, and there is another one called PL_J, which is the radius of this planet compared to Jupiter, right? So basically, this means that hat P70b is almost twice the size of Jupiter. So as I said, massive, okay? So given that I have this list, so what I created was an API based on Node.js, which I have around 5 minutes or so to show you real quick. So I created this server which lives in the Express server folder. See, it's super easy. This is Node.js code. And I'm going to show you very briefly what I did here. So I am creating Express server. This Express server, what it does is listens on port 4000. So you can see here this JSON, and this is the port 4000, and I'm exposing these planets over by this endpoint called planets. So when I say here update get planets, what I'm doing is here I'm loading all the 4202 exoplanets. I am mapping them to so I get rid of all the mess, because they are giving you around 80 fields per planet. Some of them are null because they don't know the data. Anyway, so I am transforming these planets, all the information I receive from my hard disk, because I previously downloaded this JSON file with the 4,000 planets, to this new format, which is the planets mapped to another structure with name and size. And then what I'm doing is I'm filtering out those that are null. And then what I'm doing as well is I'm sorting them by size. So that way I get the planets sorted, from the biggest to the smallest. I know you are seeing only 10, but it's because I am saying here, show me 10. If I wanted to show you 50, I save here, and now you see 50. See, but they are all sorted. They are all sorted by size. It's cool that you can sort this in JavaScript, right? If I wanted to sort them in the reverse order, I will do 1 and -1 here. And now you guys have the planet sorted by radius compared to Jupiter by in reverse order, right? So this data you see here, it can be consumed by my front end. And that front end is the part of code that shows you the planet in 3D, okay? So yeah, cool, super simple code that exposes the information in a nice way here. Here in this filtering, I could do anything you guys wanted. For example, you say, Dani, I want to see the planets filtered by a star, one star I'm gonna tell you, or I want to just filter by some of them that have a radius in one way or another. I will do, I don't know, index. So I filter by having 50, and then here I will filter, so I will do size bigger than, I don't know, 5 or 6 to see which planets are bigger than 6, right? Compare the 6. And it's only this one, which is massive, right? And if I did 5, it's even, quite unusual, right? I think the next one is 3. So let's do 2.8. And let's see. Here we have only one planet more. See, so this is one of the operations that have been very, very simplified in ES6, which is called map filter reduce. So by mapping, filter, and reducing, I am actually transforming the data from the NASA to another format I want, having only name and size. Filtering, so that means that I don't want this part. It's a subset of everything you give me. Okay, I don't want nulls. And then I'm filtering again by size. So that's really cool. I'm going to return to the previous code I had, and I'm going to show you 10 planets only. So again, I have 10 planets. I'm going to reverse the order back again, and there you go. Now we have the planets being served with real data coming from the NASA, right? So next step is showing you how I generated these random textures, right? So here in the public folder, I created these three. So these generated textures, I made them by code, right? They are made with HTML5 canvas, and I want to show you in a couple of minutes how I did them, right? I made them. So here, this code is only a support code for, as I said, right? A support code for the planets. So because with this, I generate the textures. Let me show you, right? I have some basic textures here. And then what I do is, by using this code I have here, what I do is, real quick, I load a couple of them randomly. I load one, I load another. And then what I do is, like in Photoshop, you in HTML5 canvas can change the composition modes of the layers. So that means the way I expose the pixels, right? And then, so I'm loading one texture and another texture. It's one of these textures. And randomly say it chooses this one and this one. And then it tries to mix them up. And it's doing it by exposing the pixels in an overlay mode. Then I change the color by code. Then I apply some blurring and a little bit more. And then I use this library called Reimage that what it does is allows me to download in PNG format. So let me show you how it looks. So I come here and it's texture generator. The folder is called, yeah, texture generator, and then is the index HTML. And so the index, the texture generator, what it does is it produces, see, it's producing now, I don't know if you can see it here, it says image 9, image 40, image 41, see? So it's getting random images and combining them in HTML5 canvas and with Reimage library, with the Reimage library, what I'm doing is I am saving them to my hard disk. See? So these are randomly produced textures. Let me show you how they look. I'm going to stop it because otherwise it's going to continue. So I could leave this process all night long, and then when I wake up in the morning, I have a million textures of planets. So these are some of the textures I have just generated, see? They are made with HTML5 canvas, combining two pre-existing textures, rotating them, change the hue and saturation, and so on, right? Cool, so yeah, here you have the textures, and I move them into this folder. So these are the pre-existing textures, and these are the generated textures by code. So I made 28 only, these ones, and they are in the repo that I'm sharing with you guys, so you can enjoy making your own planets. So next is, and I am 5 minutes to finish, way to finish. So now you have the random textures, and I have my front end, right? I'm going to show you now the 3D part. So it starts with this index JavaScript, the index.js. And as you can see here, I'm using the new module system that I can use these imports because I am using this Babel, which is specified in the package.json as a dependency, right? By the way, here, if you enter in the Planetarium project, which is what I'm going to be sharing with you, you guys here have all the instructions about how to install the dependencies, run the server, the API, and front end, right? So here I'm consuming my API, the 10 planets I showed you before, and then I'm sending them to my planet constructor. Here in the planet constructor, what it does is initializes the scene, which actually sets up the 3D and then creates the random star field that I showed you. Let me show you back again. So it's localhost 3000. And see, look at this detail. So I reload. See, it fades in. You have to take care, guys, about the small details. See, fade in. And also the typography, I tried to find a typography that was kind of, you know, for sci-fi. You know, you cannot use Arial here, right? Like, right? And then, so I am listening to the keyboard, and when I press G or H, I'm moving to the next planet or the previous planet, okay? As I said, you can zoom in, you can zoom out, you can pan around, right? You can see the stars here, and I can go really far away, see, and you can see the planet. This imaginary planet with this random texture producing HTML5 canvas. So I'm gonna show you the planet class, and with that I finish, because we don't have more time. And then you can, for sure, you can check all this code when I give it to you. And please don't hesitate in coming back to me through LinkedIn, through my Twitter, anything you want, guys. I am at your disposal, because helping others is something that I really makes me feel amazing. So the planet class, what it does is here I create random textures. So I create, because I have 28 random textures, I sort them in random ways. So I create different numbers. That way, every time you reload this, it's a different texture, see? Always different. And so it's loading then from this generated textures folder randomly, in random order. So here I calculate the minimum size and the maximum size of the planets in this list of 10. So the maximum is this number, the minimum is this number. And then what I do is I create a scale. So actually, what you see here, it's the planet with its real scale. That's why the next planet is half the size, see? So this is 3, coming from NASA, 3, GT loop B. And then this planet is massive, this planet is smaller, and these other ones are smaller and smaller and smaller. So here, this code makes it possible for you to have a real scale, so you guys can see how the biggest planet compared to the smallest planet of the data set that I created, they will look actually, right? Amazing. And here I load the texture, I load a random texture that I calculate here. I calculate a random number. So say I calculated number 5, so I will take image 5, load it into this variable, and then load as a material. If I didn't load this as a material, you will see an empty sphere rotating, right? And then here is when I modify by code this, see? So if I wanted to tell you hello guys as well, I would say hello guys. And then I reload here, and now the planet says the number and hello guys, see? And so here's where I'm modifying based on what I received from the API. And so every time I'm changing the planet, I always remove the planet, and then I always make the fade-in effect. And here's when I move back and forth, right? And in 2 minutes more, I wanted to show you how the scene is set up, and then I'm finishing. I'm open to questions. So this code is Three.js. Three.js is an amazing library for 3D manipulation. So what it does is I can have orbit controls. It's based on WebGL, so it's super optimized and works almost like in C++ performance, 60 frames per second in the browser. So it's absolutely awesome. You can create games, and I know like planet exploration like this, because, well, think about it. I could do this. I can go to enter full screen, and you can have this in a monitor, in a projector in your home. You could have a random planet every day. So every time you come home, every day when you come home, you have a random planet being shown here with the latest discovery from the NASA or something, right? So you always want to do some creativity, right, with code here, and you can do amazing stuff. And just to finish, I'm going to show you here how the planet is rotating. So you have the star field. You have the lights, and you have the play function. And the play function is moving the mesh in the Y. So the Y is the axis, like going across the planet. So if I did this, I don't know, 55, this will be super fast. See? Now it moves way faster because I am rotating it over the Y axis. And now you can make it on the Z and on the X, and you will see it rotating in all directions, right? Like crazy. See? See? So, as I said, I know it's a lot of code, but I wanted to give you something viable, guys, something that you can experiment with and something that makes you feel passion. In my case, it's astronomy and data analysis. I hope we can keep in touch. You have my contact. And as I said, if you have any questions about this code, or you want to extend this project much farther and create something cool, you don't know how to start, I am available to help you and to answer any questions. Once again, to the organizers and to all of you folks, thank you very much indeed. I'm really, really happy to be here with you, and greetings from Madrid.